Hello, this is Ms. DB, and in this lesson we're going to go over Chapter 8, Section 3 on solving right triangles. It's very important that you know how to do Section 2 first, where we introduce the trig ratios of sine, cosine, and tangent, because we'll be using those in this lesson as well. So our objective is to use trig ratios to find angle measures in right triangles and to solve real-world problems. In the last lesson, we used trig ratios to find missing sides of triangles. Now we'll be able to also find the angle measures. So this is a review from last lesson, sine, cosine, and tangent. You should have that written down in your notes or have it memorized. Okay, here's our example situation to kind of introduce this lesson. San Francisco is famous for its steep streets. The steepness of a road is often expressed as a percent grade. Not a grade like ABCD, but it's the grade of the street. Filbert Street, the steepest street in San Francisco, has a 31.5% grade. It's very steep. This means the road rises 31.5 feet over a horizontal distance of 100 feet, which is equivalent to a 17.5% or 5-degree angle. You can use trig ratios to change a percent grade to an angle measure, like here, because the angle measures are more helpful for us in math. You can watch the lesson video, the Edward Berger one that goes along with your textbook, in order to see exactly how to do this. I'm just going to kind of briefly go over it. But this is... I think he does this in example 1. All right, so here's our triangle, and we have a short leg of 1.4, we have a long leg of 4.8, and we have a hypotenuse of 5. We have everything we need to know about the sides, but we don't know either angle in this one. We know it's a right triangle, but we don't know what angle 1 or angle 2 is. So what we're going to do is... this is actually incorrect. Ignore that. It must have been left over from some other problem. We are going to figure out if we should use sine, cosine, or tangent to find one of these angles. Now, they may tell you which one to use, but in this problem, since you know all 3 sides, you could use any of them to find a missing angle. And what you're going to do is, in the problems, you might be asked to find one of the angles first and then find the other angle using the triangle sum theorem that you know all the angles in a triangle add up to 180. All right, so let's use cosine. And we are going to try to find angle, I'm not sure which one they think angle A is here. So they're talking about angle 1. So they're going to use this angle. They want to find angle 1. Okay, so angle 1, if I want to use the cosine, I would need the adjacent side over the hypotenuse, because cosine is equal to the adjacent over the hypotenuse. That in SOHCAHTOA, this is the ka part. So I'm going to plug in the 1.4 and the 5, so 1.4 over 5, and I get 7 over 25. Now we're not done yet. That's the cosine of angle 1. I need to know what is the measure of angle 1. All right, so now you're going to... Oh, they just want a ratio. So this time we're just writing the ratio. And the cosine of angle 2 would be... why are they doing this? So for some reason they multiplied both of these by 5. I don't know. There must have been another situation somewhere that is missing in this picture. But you could just write this as the ratio. This is just an introduction to setting up your ratios. You don't have to worry about this. What we will be doing then is using our calculators to find the angles, angle 1 and angle 2. All right, so in this one, to determine which angle of the triangle is angle A, it's kind of a bizarre problem. Okay, so in this one we have 27, we have 14.4, and we have the hypotenuse. They say which of the angle of the triangle is angle A. You really could call either of these angle A, so I'm not really sure what they're getting at here. But they decided to use the sine. They want to find the ratio to find angle 1. You could use sine and do 27 over 30.6. This should be the word opposite. I'm sorry, I should have proofread this before I started doing my video. I just thought the slides were going to be correct. And then if you want, you could change that to a decimal. But this is the ratio right here. And you could use the sine of, you could find the sine of angle 2 by going opposite over hypotenuse. And that would be 14.4 over 30.6. We're going to move on to the next example. All right, so if you remember our 30, 60, 90 triangle, I'm going to set this up. Let's say this is 30, this is our 60, and this is our 90 degree. If you know the short leg times 2 is equal to the hypotenuse, and the short leg times the square root of 3 is equal to the long leg. So if you find the sine of 30 degrees, sine is equal to the opposite over the hypotenuse, you would see that the s's would cancel and you'd be left with 1/2. The sine of 30 degrees is always equal to 1/2 or 0.5. That means that if we were given a triangle and we wanted to find, let's say, the measure of angle A, and we knew that this was 3 and let's say this was 6, then we could say, okay, the sine of A is equal to the opposite over the hypotenuse. So the sine of A is equal to, I'll simplify that to 1/2 or 0.5. And then you might say, wait a minute, if the sine of A is equal to 0.5, then A must be a 30-degree angle. So for special triangles, we can memorize the sine of 30, the cosine of 30, the tangent of 30, and the same thing for 60 and the same thing for 45. For all the other angles, we'll use a calculator in order to find it. So what we're really going to be finding is the inverse of sine of A. So if the sine of A equals 0.5, that means the inverse sine, which we'll use the little -1, of 0.5 is equal to A. So we're really just kind of doing the opposite. We're doing the inverse. Instead of knowing the angle and taking the sine of it, we're knowing what the sine of that is equal to, and then we can use our calculators or sometimes special right triangles in order to find the angle measure. And this is in your book, but this is something you want to add to your notes. If the sine of A is equal to x, then the inverse sine of x is equal to the measure of angle A. So see, here's our x. This would be, if you type this in your calculator, you'd get a decimal number. And that means if you know that number, then you can find the measure of angle A. If the cosine of A equals x, then the inverse cosine of x is equal to the measure of angle A. And the same thing for tangent. If you know what the tangent is, then the inverse tangent is equal to the measure of the angle. So these are called inverse trigonometric functions. Very handy. Now on your calculator, there is a little button, and it's usually the second function, or sometimes shift cosine, or shift sine, or shift tangent, to get to the one that looks like this. It'll have the trig function, sine, cosine, or tangent, with the little -1 as the exponent. That means inverse cosine. So in letter A here, they want the inverse cosine of 0.87. What they're really saying is that will be equal to some angle. Oh, I accidentally went through all of them at the same time. So on your calculator, you want to check and make sure. First of all, it has to be in degrees. And then you want to find the inverse cos. And then you type in the 0.87 and then hit equals or enter. And you should get this. that means that the angle is equal to 29.54. Now, this one said to round to the nearest degree. Usually we'll just leave it as like 2 decimal points. And then this is the inverse sine, and then this one is the inverse tan. So pause the video that you're watching and make sure that you will get these same things on your calculator as what's showing on these screens right here. Because you want to make sure that your calculator is set up so that it'll correctly calculate these amounts, because if they're not right, then your whole problem is going to be off. You need a scientific calculator to do this. I'll show you the one on the calculator, the one on the computer. All right, so in order to use inverse functions on here, see, there is no little second function or anything. See that? They're not quite the same. So where was it? I found it on here earlier. Is it this? Yeah. So if you're using the calculator, you push this arrow key, and that's like your second or your shift. So now I can do sine inverse of 0.87, but in this calculator it's kind of backwards, and I have to type in the 0.87 first and then hit inverse sine. And I did the wrong problem, sorry. I was supposed to do cosine for that one. Cosine of 0.87, so 0.87, and then inverse cosine is 29. See, it matches. And on the next one, it's 0.85, and then inverse sine, and that number should match this number, yep. And then 0.71 inverse tan, yep, that matches. So on if you're using the calculator on the computer, yours might look different than this. This is just the one that came with my computer that I have installed on mine. All right, so next thing we're going to do then is, this is just more practice. If you need to check that, you can go ahead and pause it and check your answers there. What we're going to use this for is to solve a triangle. Okay, solving a right triangle means that you need to know every missing side and every missing angle. There's usually 3 things you'll have to find. They have to tell you at least that you have a right triangle. You have to know you have a right triangle, or you're stuck, because these trig functions only work with right triangles. And you need to know at least 2 side measures. If you know 3 side measures, then you need to find the angles. If you're given 1 angle and 1 side, that's good. You need at least 2 things in addition to that it's a right triangle. And you can use things that we've done before, like the Pythagorean theorem. You could use the Pythagorean theorem to find side, I'll call this side R. Or you could use, what else could we use to find side R? We could find an angle first, and then we could use trig after that. So they went through the Pythagorean theorem and got, did I go one step too far? Yeah, here we go. So they got that R, or what I called R, side ST is equal to 2.74. So I've got I have to do 3 things. I've got 1 part done. The second part you have to do is find the missing angles. So we've got 2 angles to find. Now you're going to need trigonometry. There's no way to do this without trig. So you could say, let's use what we're given. Let's say that the sine, I'm going to do it different than them. We could do the sine of t is equal to the opposite side over the hypotenuse. Well, that means that the inverse sine of 5 over 5.7 will be equal to the measure of angle t. Now, they did it different. They used inverse cosine to find the measure of angle r, and they got that it was 29 degrees. They used inverse cosine of the adjacent side to angle r over the hypotenuse, and they typed this in there. This is a calculator problem. And then they hit enter, and they got 29 degrees. And then you can use the third angles theorem, or no, not the third angles theorem, the triangle sum theorem, to say that all three of these angles together will add up to 90 degrees. If you already had the 90, you could subtract that and say that if this is, let's see, what's this one, 29, then this one must be 61. But you could also find the measure of angle T with trig, and then you could find the measure of angle R with trig the way they did here. You don't have to use the triangle sum theorem. This is just another example. In this one, they found the missing side, kind of complicated, like. All right, let's look at this one. They say solve the triangle. That means to find everything you need to know. And there's more than one way to begin this. Now, in this one, you can't use the Pythagorean theorem because you're missing two sides. I'm going to call this side D, and I'm going to call this side E. So let's see. We could find the measure of angle D pretty easy, because it'll be equal to 180 minus 90, which is 90, and then 90 minus 58. So that one's easy to find. Usually there's one part of your triangle that you can find without trigonometry. Then after that, you're going to have to use some trig. We are given that we know both angles, and we know that this long leg here is 14. So we could find side E by saying the sine of 58 is equal to the opposite side of 14 over the hypotenuse of E. We could do that. Or you could do cosine of 32 is equal to the adjacent to that is 14 over the hypotenuse. That's almost the same thing. You could even use tangent. You could use the tangent of, I can't use tangent to find E. I could use tangent to find D though. I could say tangent of 58 is equal to the opposite over the adjacent, or you could say the tangent of 32 is equal to the opposite D over 14. Pick any two of those, pick one of these, and pick one of these, and you'll find E and D, side E and side D. So let's see, they did tangent of 32, which is this one, and they found that side EF, or what I call D, is equal to 8.75. And then let's see what they picked for their other one. Oh, they used Pythagorean theorem after that. You can. I would probably just go ahead and use trig now that we have that tool in our math toolbox. And they got 16.51 for the hypotenuse. Don't forget that when you are using Pythagorean theorem, that it's the two legs next to the right angle squared will be equal to the hypotenuse squared. Now, if you don't know the hypotenuse, you'll be subtracting. Or, if you don't know one of the legs, you'll be subtracting in order to solve, not adding, if you're using Pythagorean theorem. All right, we can also place these on a coordinate plane. And why would we do that? We would do that so that we would find the lengths of some sides. These are right triangles, so in most cases, they are going to be nice to you, and they're going to have two legs right along the either parallel to the x-axis and the y-axis. So for two of these lengths, you can just count 1, 2, 3, 4. This is a length of 5, and this one is a length of 1, 2, 3, 4, 5, 6, 7. So I would probably use Pythagorean theorem in this case, and then you would find, I'll call this side H. Now we're going to have to use trig to find the angle R and angle Q. This time we are given that the they didn't use Pythagorean theorem. They used the distance formula, which also would work, and they got 8.6. Distance formula really is the Pythagorean theorem. It's just written as a formula. And now to find the angle measures, we already knew that measure of angle P is 90 degrees, and then you're going to have to use some trigonometry. So to find the measure of angle Q, what was this one was 5 and this one was 7? You can say I always write it like this. The tangent of Q is equal to 7 over 5 opposite over adjacent. Well, what does that mean? That means that the inverse tangent of 7/5 is equal to Q, which is what we're looking for, the measure of angle Q. So now we get the calculator out. Let me show you on the calculator what I would do. Calculator. So I'm going to type in the inverse tan of 7/5. Now, what I'm going to do, let me clear this out, is 7 divided by 5. And if that was a whole bunch of digits, I would just leave them all on there, even if it was really long. And it's 1.4. And now I'm going to go inverse tan. So the inverse tan of 1.4 is that number there, 54.46. So that's angle Q. Measure of angle Q is about 54.46. Now they said that that's about 54. It's pretty close to 54.5, but they're rounding quite a bit. And then we have to find the measure of the other one. And you could do that by what they did, 90 minus 54, or you could find the inverse tan of R would be 5/7. So you could do that and see what you get. And you'll get something close to 36. I think it's closer to 35.5, but that's okay. Okay. One more little application with the road grade. This will be a good kind of extra credit question on the quiz. It says, to the nearest degree, what angle does the road make with a horizontal line? 7% is the same as 7/100, so change that to a fraction. And that means that the road rises, or if it's going downhill, it falls 7 feet for every 100 feet of a horizontal distance. So a triangle will definitely help with that in a picture. So 100 feet, this is not drawn to scale, and here's your 7, little skinny triangle. And we're looking for angle A, because we want to know what angle does the road make with the horizontal line. So we're going to have to use some trigonometry. So you know there's sine, you know there's cosine, you know there's tangent. Which one would let you find angle A? Sine is opposite over hypotenuse. We don't know the hypotenuse. We could find it with Pythagorean theorem. Cosine is adjacent over hypotenuse. There's that hypotenuse again. But tangent, we wouldn't have to find the hypotenuse because tangent is opposite over adjacent. So again, they're skipping this step, but I would write on my paper, I would write that the tangent of A is equal to the opposite of 7 over the adjacent of 100. So this is a true statement. Tangent of A is equal to 7/100. But then we learned in this lesson that the inverse tan of that answer of 7/100 is equal to the measure of angle A. It's equal to what we're looking for. And that's right here, that's what they wrote here. So then you get your calculator out and you find 7 divided by 100, and you don't round it. 7 divided by 100 is going to be 0.07. 7 divided by 100. And then you leave all those digits on there, and you then hit the inverse tan button. Now, if on your calculator you have to type the inverse tan first, which some people do, a lot of calculators do, then use your parentheses key and go 7 divided by 100. And close your parentheses to get the 0.07, and then hit equals. So then you would have the inverse tan of 7 divided by 100 is equal to that. Or you can use a fraction key if you have that too. And that's about it. These aren't hard, but do make sure that if the problem says to solve the triangle, solve the right triangle, it means to find all the missing parts. Missing angles and missing side lengths. Whatever is missing, that's what you need to find in order to solve the right triangle. Thanks a lot and have a great day.